Hello YouTube. So today we're going to continue our Ospf journey. Um, if we look at the network that we have here, I've made some bit of changes, but I'm going to explain to you exactly what I did. But a quick recap of what we did previously is we built our Ospf in area 0, area 1, area 2. We also added ERGRP area, okay, or AS50. We added also a RIP area. Okay, so we have a RIP area here. What I did is I basically separated the RIP area. Okay, this network you see here, this interface is goes straight to this other interface here. Okay, I just used the cloud bridging feature of EVNG to be able to bridge this network so that, okay, even though they're separated, but actually they're the same network. Okay, that's why you have RIP here, you have RIP here. I'm going to explain to you exactly how I did it, but I could actually show you right away. Like if I go in here if I go to the properties of this this one, okay, I named it init 2. Okay, there I named it init 3, so a different interface name. Also, I made it to be cloud 2 here. You're going to see there it's also a cloud 2. Okay, and the reason it has to be the same type so that I can now put an IP address on the same, the same interface. Okay, so the icon is also symbolic, but I needed to show you this because of what I'm going to explain later on. Okay, because I made this area. Okay, it's an area type that's called NSSA. Okay, so we're going to see why I called it NSSA. So that's why I had to draw this, make this difference for you. Let me just go into init 2 cloud here. Let's edit it. You see I gave this name init 2, init 3 here, and the name has to be different. And I made sure it's cloud 2, just like I named the other side. And then the icon here is symbolic, but I wanted to use this one instead of that one for the explanation that I'm going to give when I'm doing this. I'm showing you exactly why I named it NSSA. Okay, so now in the previous video, we made it possible for ERGRP routes to be injected into OSPF and OSPF routes injected to ERGRP so that router R8 could have full visibility on all the other routers and be able to go to internet. Okay, we made the same thing here on ASBR router. Okay, autonomous system boundary router here, ASBR router 9. And why is it called ASBR? Is because it links an area, OSPF area with a non-OSPF area, which is a RIP area here. The thing with router 4 is an ASBR. Okay, ASBR. Okay, if you contrast that with the ASB area, okay, autonomous area boundary router, this is router 3 here, and area boundary router 5 here. Okay, they link up. They're the routers that bore different areas of OSPF, okay, area 1 and area 0. All right, so if we go into R8, okay, for example, or we can go R10, but let's take R8 for example, just to. Okay, so from here, if I do show IP route, okay, you can see we have our default route, which is very important. That one will be able to go out to anywhere. And we have all these networks coming from all the other. So just to tell you that we have convergence, okay, we have full convergence, and R8 can be able to see non-ERGRP running route. Networks. Okay, so our network is fully converged. The same thing, we go to R10. If I go to R10 here, if I do show IP route R10, very important, we see that there's a default RIP route, which is very important, which permits this R10 to be able to go anywhere on the internet. So we have all these routes coming from everywhere. It means from R10, we should be able to do everything, plus even going out to the internet. Okay, let's say Cloudflare IP address. Okay, thing is working. Even if we want to, we can go to terminal, say IP. IP. IP domain, let's see, IP. Domain, okay, IP domain lookup. And I also have IP name server. Okay, let's call it, let's use the Google DNS this time. Okay, it really doesn't matter. Or I could even use my internal 92168.18. This is actually internal DNS server. Okay, and if I go out of there and I ping cisco.com, okay, that's pinging. So I could actually say that just to show you that from R10, this one, we're able to go out. Internet, if I can show you the traffic flow, it goes from R10, okay, come here, goes to R9, to R7, to R3, to R2, R1, and then out to the internet. Okay, so that's working. Now, the purpose of this video today is to tell you how in OSPF we could further do something like reducing the routing table. Okay, so for that one, let's go to R6. Okay, let's go to R6 and see exactly. And just let you know, I'm trying to do these videos from point of view of teaching myself things that I probably forgot, and also I have to reference people on the internet who do this job much better as far as explaining concepts. So I'm also trying to learn as well. If you have questions, you can always ask. But yeah. So, anyways, so on R6, if I do on R6, okay, not knowing that R6 is on OSPF, I do show IP route. Okay, we have the default external OSPF route. Okay, we also have inter-area routes, OSPF routes, and we also have external routes. Okay, external OSPF routes. Okay, so this is the this is the external OSPF routes, inter-area routes, OSPF routes, and then this is the default OSPF route. So let me just try to do something else. I'm going to filter all these default routes. I'm going to do this. I'm going to do include okay. Okay. So now we're watching only the default. We're watching only the external OSPF routes. Okay. So let's assume that since we have the default default external OSPF route, we could as well see how we can convert this area, okay, into a stop area. Like you see here, stop. If we convert this area to stop area, our purpose would be to make sure that we can still have the default route here, and we're going to filter all other routes. Okay, because with that in mind, if we have our default route, then why should we still have these other routes here? Okay, so that's basically making our routing table to be very big. So for that to be achieved, we have to convert this area into a stop area, and that has to be done on router 5 and router 6. Okay. Now, before converting, what is a stop area? Okay. So imagine that you have a head office. Okay. Let's say router 1, router 2 are in head office, or let's say router 2 is a head office router, And so your router 6, okay, is actually a branch router, which means beyond this, there are no other, nothing connected. There's no other routers that are within your organization, okay? So that's why we can convert this to a stub area. We don't expect any OSPF route updates coming out from the other side of router 6. So its outlet to internet goes through the main office here. Okay, that's the main outlet to the internet, to the outside world. Okay, that's why we can confidently convert this area to a stub area. Okay, with router, we'll do the configuration on router 6 and router 5. So that's a stub area. Okay, we have only one exit to the internet. All right, so let's convert this area to stub area. We'll just go into the router 6. Okay, let's start with router 6. No, we start with router 5, the ABR router. So go configure terminal. We say router OSPF1. Okay, and the command is going to be area 2. Stop. Okay, we'll do the exact same thing on router 6. Save. On router 6, do the exact same thing. Configure terminal. Router OS1. Area 2. Stop. Okay. Okay. Now, with that in mind, let me just save this. Now let's compare. We're going to see what the routing table will get now on router 6. Okay. Remember, even though we've made this command on both router 5 and router 6, we're only going to be able to see those reduced routes on router 6 because router 5 still remains the gateway for router 6 to go out the internet. So on router 5, you're still going to be able to see all those routes, okay? Because if you don't see them on router 5, then R6 is completely isolated. Okay, so converting this area to the stub area actually affects mostly router 6. Okay, so let's do short IP route. Okay, I'm going to include OSPF external route. Okay, E2. Okay, so let me just clear IP OSPF process. Okay, yes. Okay, now I'll do it again. Okay, so let me just show IP route. Okay, I wasn't expecting to see the external OSPF route, but I just wanted to show you that they are no longer there. They're all gone. Okay, so all the external OSPF routes are all gone. Okay, now what we have left is mostly the inter-area OSPF routes. Now, even then, we see that there are a lot of inter-area OSPF routes. Okay, if I do OSPF inter-area, okay, so this is a lab environment, and you may say, okay, well, there are not so many, but in reality, sometimes in a real work environment, this could be a lot. This could be, I don't know, hundreds, thousands of routes like this. So how do we reduce them? We declare this area to be a stub area, okay? But there's another way we could do it. Since we have these inter-area routes coming in, we could, because of these inter-area routes, okay, coming in, we could actually declare this area as completely totally stub, okay? Instead of just stub, we're going to convert it to totally stubby area. In that way, we're going to eliminate even the inter-area routes. Okay, we're going to be left only with the inter-area default route. Okay, just like if I do right now, if I do show IP route, okay, so we still have our default route, which is inter-area. So what we want to do right now is we want to eliminate all the inter-area routes, and we're going to be left only with the inter-area default route, this one. Okay, so to do that, first let's test if we are able to reach the some of those routes that we got filtered, okay, by the converting this area to stop area. So one of the routes that got filtered was the what I mean is the route OE2 routes. Okay, those OE2 routes. Let's try to see if we can reach any one of them. One of them was the if I ping, let's say on the 10 network, it's going to be 110.0.4.10. Okay, let's source from loopback 4. Okay, so ping is going. Okay, so what is loopback 4? Show IP interface brief. Should told you about this, but what happened is I added some loopback interfaces on R6, and I added them. We didn't see them in the previous video. I added these loopback interfaces because we're going to need them for demonstration on the other side when we're doing the NSSA, okay, not so stubby area. So I added these loopback interfaces on our area 6. Okay, that's why I'm sourcing traffic from them. I'm pinging the R10 side. And that ping is successful. Why? Ping is successful even though if I do show IP route, I do 1.0.0.4.0. If I do that, it says it doesn't see that route, okay, in our routing table. But if I ping, okay, okay, I source from loopback 4, ping is working. So how is it working? It's because we have a default route. Okay, show IP route. We'll have a default route that's saying if you don't see anything, please forward your traffic out to this interface. Okay, so we'll have that default route right here. That's permitting us to be able to ping router 10. Okay, so let me, right now we have on router 10, on router show IP route. Okay, so I was saying we're having all these inter-area routes. We need to filter them. We need to filter because there's no need to keep inter-area routes if we have a default route. Okay, if we do have a default route, then we can as well filter this in a totally stubby area. Okay, so let's convert this area once more into a totally stubby area, and that's going to be done only on the ASBR, on the ABR. Okay, not on this one. This one is already converted as a stub. So this one, now we're going to issue another command only on the ABR that converts this area once more into completely totally stubby area. Okay. Okay, let's go into routers 5. Okay, we're in router 5 now. And remember this command to convert to completely totally stubby area. You can only do it after making the router the area a stub area. Okay, you cannot jump straight to converting to totally stubby area without first converting it to a stubby area. So if I do show run router, okay, on router 5, ABR router, okay, we see it's already a stubby area. Now we can convert it to a totally stubby area. Okay, since it's already a stubby area, so I'm going to say configure terminal. Let's say the OS area 1, area 2, stop Okay, so area 2 stub, if I do question mark, okay. So if you see here, these are the options we have here. I'm going to use this option here. Do not send summary LAC routes into the area. Okay, so I'm going to say no summary. Okay, I'm going to save. That's the ABR on the ABR, and now I go back to R6. Go back to R6 and to clear IP Ospf process. Yes. Do show IP route. Let's see what we get there. Okay. Not yet converged. We don't have yet the IP route. Wait. Okay. Good. The good stuff. So now we have our default inter-area route. Okay, we have a default inter-area route. That's what we want. Okay, as long as this route is there, we can be able to go out to the internet or anywhere from router 6. Okay, so we have our default route there. We don't have all those inter-area routes are gone. The inter-area, Ospf external routes are also gone. Okay, so if I do a ping again to 110.0.4.10, okay, if I source the ping from loopback 4, okay, so our ping is working. How? Because we have a default route. Okay, so that's done, and that's how you convert an area from stubby to totally stubby. Okay, first you have to make it stubby and then make it totally stubby. Okay, and that way, it eliminates all the Ospf external routes and the Ospf inter-area routes, okay, that are received on the stub area and the stub router. Okay, now let's go to this side. On the other side, we will have area 1. Sorry. So if you go into router 7, let's go into router 7. Okay, which is supposed to be in this. There's a router that's configured directly in the routers in the area 1 completely. If I do show IP route, okay, so here it's the same thing. We have our default route, we have inter-area routes, we have Ospf external routes, okay, and we have all these routes. There's so many of them. And by the way, if I had to do something more like this, like filter include EP okay. So our mission here is to be able to filter all routes that are inter-area, okay, Ospf, and also Ospf external route. That's our mission here. So how do we go about that? Now in this other area 1, just like we explained here, suppose this is one of those branch office routers, and that branch office router has another separate, in addition to having the connection to the internet through the main head office, it also has its own internet or another internet link, okay, going out. Okay, that's exactly what I'm trying to show here. So in addition to our branch office or our head office link, okay, that goes to the internet, we also have another link that goes to another private internet here. So this area is an Ospf area, but it's not going to be a totally stubby area. It's going to be not so stubby area, NSSA. Okay, that's why it's called NSSA. So how do we actually convert this? Now it's just a name. Okay, how do we actually convert this to not so stubby area? And what is the purpose of this? The purpose, of course, is exactly what we saw previously. Okay, the purpose is to be able to reduce this routing, the routing table. Okay, we have a lot of routes here, And why would you keep all these routes if we actually have a default route? Okay, if we have a default route like this one here that permits us to go to the head office, okay, go to the internet through the head office, why are we able to keep, why are we still keeping these other routes, okay, that are known also through the same default route? Okay, so that's the point here. The point is this default route goes out through this router, and all these other inter-area OSPF routes, we know them only through the same link. Okay, so our goal is to be able to eliminate the inter-area OSPF routes as well as the inter-area as well as the OSPF external routes. Okay, so let's get into it. How do we actually keep this? Right, so to achieve this, we're going to go in several steps. The first step is to convert the area into NSSA area. Okay, so we're going to do that on router 3, router 7, and router 9. Okay, which is our ASBR. So let's pull out routers. We're going to pull out router 3 first. Okay, this is router 3. Let's check what routing configuration is on it. Show IP. Show run router. Okay. Okay. Anyways, yeah. So that's the configuration we have for the for OSPF on router 3. We're going to say configure terminal. Okay. Router OSPF process 1. Okay, and so now we're going to have to convert this to master stub area. Okay, so how do we do that? We do on the area 1. Okay, we just call it the question mark. So we're going to convert it to NSSA. Okay, so that's the command we have to put here, NSSA, and that's it. Go out of there, we'll save, and we'll go to router. We just did it in router 3, but now we have to go on router 7. Okay, on router 7, we just actually use this other map here. Okay, router 7. Okay, so run just to be sure what we're doing. Be sure that there's no configuration of that type already existing on router 7. Okay, so now we go configure terminal. Okay, we say router OSPF process 1, and we say area 1. Yes. Okay, that's it for router. That's it for router 7. Okay. NSA is configured for router 7. Now we just left with router 9. Going to router 9. Okay, let's check what configuration is on router 9. Show run router OSPF. Okay. Okay, so no that configuration is there. Okay, so now we have to go into configuration mode. Router OSPF process 1, area 1. Okay, just like that, we have converted this area. Okay, so I just did the configuration on router 3, router 7, and router 9, and just like that, we've converted this area into a non-star stubby area. Okay, how do we know it's a non-star stubby area? We're going to go into router, essentially router 9, it's router 7 because it's within the area. Okay, if you go in here, we're going to see many other routes, especially the routes coming from RIP routes. But we want to go into router 7 so that we'll actually see exactly what routes have been eliminated on router 7. We're there before. I'm going to go to router 7. We do show IP route. Okay. So we still have our inter-area routes. Okay, we haven't done anything about that. Now we have some new routes here coming in. There's Ospf N2 is actually not so stubby area. Okay, Ospf not so stubby routes. So if you come here, we check N2. What does N2 stand for? N2 is the Ospf NSSA external type 2 routes. Okay, so these are the routes we're getting here right now. And if you look at closely, you see those routes are coming from, they are the RIP routes. Okay, so what happened is that the RIP routes now are coming in to R7 as non-stubby area routes. Okay, so that's what we got. And but if I do on R7 show IP route, let's assume we wanted to stop here. We don't want to do any more filtering. We're done. Okay, so if I do that one here, you see if you see we're losing the default route. Okay, we don't have a default route, so in essence we cannot go out of here. We cannot go out to, even if I try to ping router 1, I cannot ping it. If I ping router 2, it should not, that's not going to be possible. Okay, because we don't have a default route. So let's try it. Try to ping, try pinging router 2, ping 2.2.2.2 source. Our ping is working. So actually what's going on is, if I want to go out of the internet, okay, our internet, I wouldn't be able to go because it's actually not default route. The reason why we're able to ping router 2 is because we have our inter-area routes are still here. Okay, that's why we're able to ping 2. So my assumption was wrong, because I didn't take into consideration the fact that we have our inter-area OSPF route still here. But if I want to ping the internet, that should fail. Okay, that should fail. Why? Because again, we don't have a default route. So let's assume I want to ping internet. So it's going to be 1.1.1.1. Okay. Okay, ping is failing. Okay. Why is it failing? Because we don't have a default route. Let's wait for it to complete. Okay. Let me just click on the ping. Let's assume we want to ping even 8.8.4. We want to source traffic from port 0. Okay. So just to confirm to you that ping is not working. So we successfully converted this area into a not so stubby area. Okay. We can see RIP routes coming in here. We can actually ping all the networks that are in OSPF, but we cannot go internet. We cannot even go to we cannot ping. We didn't try it, but we cannot also ping the router 8. We shouldn't be able to ping because we can only see the inter-area route. R8 is OSPF external route, which has been filtered. Okay, so we cannot ping it as well. Okay, so what's going on is that we have to find a way to fix this. The fact that we don't have a default route, we don't have to. So we'll have to fix that before we can go further. So to fix that, we have to tell these other routers that if you want to go out to the internet, to the head office, you have to talk to this router. Okay, so we have to configure default information originate on this router. Okay, for the NSSA routes here on this area 1 to be able to go out internet through the head office. So let's go to router 3. Okay, let's go to router 3. We'll do show 1 router. Okay, session router. Just want to be sure everything is there. So this area is converted to NSSA. Okay, now I'm going to issue the command default information originate. Okay, OSPF default information originate on this router. I'm going to go configure terminal, router OSPF. This is one. First, I have to remove this, but I'm going to add it with the statement default information originate. So I'm going to have to remove this one first. But if I don't remove, that command is not going to go in. So I'm going to say area 1. Area 1 is okay. And if I do question mark, okay. So what I need is this one, default information originate. That's all I need. But it's still going to be an NSSA area. Okay. In addition to that, this command default information originate. Okay. So if I do that, only and that can be done only on the ABR. Okay. So if I do that, I save. What that does is that it's going to push the default route from the ABR to the other routers in the area 1, and also that's R7 and R9. Okay. It's going to push that default route to these other routers beyond it. Okay, so let's go to R7 just to double check that. So before in R7 we didn't have a default route. So if I go show IP route, now we're going to see we have a default route. Okay, now we have a default route. And what type of route is it? It's a default OSPF NSSA. Okay, signal type 2 route. Okay, so that default route is there. It doesn't matter what it is, but at least we have a default route. What that means is if I want to ping, let's say I want to ping even internet. Okay, let me say I want to ping. Okay, so it's traffic from loopback 0. Okay, that ping works. Okay. Then in the same way, I could also ping router 8, which is in a completely different autonomous system, which is the ERGRP route. Should be able to ping it now. Let's say 8.1.1.8. That's the loopback interface we configured on router 8. We're going to source that traffic from loopback 4 or loopback 0 of R7. That ping works as well. And the reason it's working, of course, is again is the default route. Okay, so now we have a default route. If I do show IP route, so now we have a default route. Okay, but we still have a lot of inter-area OSPF routes, a lot of them. Okay, we still have a lot of them. So right now we're going to say, how do we reduce this OSPF inter-area routes? Okay. How do we reduce them? How do we make this routing table smaller on the R7, okay, which is supposed to be a not so stubby area? Okay. All right. So how do we do that? So if we go in here on R7 again, let's just check how many routes we're getting. OSPF area. Okay. OSPF into. Okay. Let's see how many of those we're getting. Okay, so we're getting quite a lot of inter-area routes. Okay, and as again, in a lab environment there may be few, but in reality, if in a working environment we have this in their hundreds and their thousands. So this is a very important step here where we go further to eliminate this OSPF inter-area route, knowing that we have a default route. Okay, as long as we can maintain a default route. Okay, so we don't need this all these areas, because in any case they're still pointing to the same exit point. Okay, so how do we do that? We're going to go into our ABR and then issue a command that converts this area from NSSA to NSSA totally stop. Okay, so now it's NSSA stop. We're going to convert it to NSSA totally stop. and that command is going to be done only on the R3. Okay, let's go into R3. Let's go into R3. Go terminal. Before doing that, let's just check. Okay, we can just terminal. Go to press BF1. Okay, process 1. Now let's do show run router. Okay, let's just see what we have. Okay, so what we're going to do, we're going to convert this area now from NSA stub to NSA totally stubby. Okay, so for that we have to again remove this command. Okay, we're going to remove this command because the two cannot be together. But the good thing is that the new command I'm going to put, it is going to inject on the default gateway, a default route, okay, into the OSPF area 1 area, and also it's going to make sure that this is going to convert this area as well to NSA. Okay, so I'm going to say no. Okay, now I'm going to issue this command, area 1, SSA, okay, by the question mark, the node summary. Okay, we saw this before here, but now it's an NSSA totally stubby. Okay, we saw this one for the stub area, but this one is going to be NSSA totally stubby. Okay, so just with this command alone, just with this command alone, we have this area maintained as NSSA, and again we also have a default route that should be showing in router 7, router 9, and even router 10. Okay, router 10 here. So let's go into router 7 just to be sure. Just to be sure of what we're saying. If I go into router 7, as we show IP route. Okay, so now previously we had default NSSA. Okay, default NSA route, but now we have a default inter-area route. Okay, but in any case, we have a default route. We have a default route, and if you look closely, all those inter-area routes are all gone. Okay, what we have is the N2 route, which basically are the routes are coming from our directly connected, the R10. Okay, route 10 here. So those routes we see them here, which is okay. But at least they have been converted to. Now those routes are being injected to the OSPF area. Okay, without we can now ping. If I now let me ping from router 7 to internet. Okay, so start from loopback 0. Okay, ping is working. I can also ping router 8.1.1.8. First traffic from loopback 0. Okay, ping is working. So that's just let you know how our goal is achieved. Okay, so I've been doing all these tests on router 7 because I know router 7 is fully in the NSSA area, but I could still do the same test on router 9, sorry, and even on router 10 I could do it, but just test connectivity, full connectivity. Okay, so let's go to router 10 just to be sure. Because all along we haven't checked on router 10 what's actually going on. Okay, let's go to router 10. Okay, let's go to router 10 just to be sure it has full connectivity. Let's do show IP route. Okay, so router 10, what's router 10 seeing? It's able to see the most important here. the default route. Okay, so we have a default route, and where does it point? It points to router 9. That's what we want. Okay, so forget about these other ones. Okay, we do have read routes, they're not complete. We have read route coming from 7 network, from the 9 network, you know. But what's most important is that we have a default route. Okay, and also you're going to see that on router 10 also the route has been reduced. The route has been reduced because we converted this area 1 into an NSSA area. Okay, so as long as this area is an NSSA area, the routes on router 10 are also reduced. But since we have a default route on router 10, we can ping the internet. Okay, and I think we actually on router 10, I think we could also ping even the Google DNS. Okay, let's ping google.com. Okay, ping is working because I think I configured a DNS and IP lookup on router 10. So that's working, and basically that's it for this video. And let me just see if there's anything that I missed. Yeah, that's it for this video. I think I don't want to make it long either. So I think we've covered mostly what we can cover on this OSPF series. So this is going to be basically it for OSPF, and next videos probably is going to be not dynamic routing, it could be something else, but I haven't thought about it. But this is it for OSPF. Thanks so much for watching, and talk to you in the next video.